All right, so I'm here to give a little update on SIG spec. So, I realize a lot of you are probably new here. Andrew mentioned earlier that, we have this concept of SIGs or special interest groups. These are like long-running groups in the community that are focused on certain aspects. And it's not just developing new things in SPIFFE, but it's also kind of maintaining and keeping the lights on. So I'm giving an update on this one called SIG specs, or it's short for SIG specification. It is the most active SIG in the SPIFFE community. And it is the SIG which is focused around the shepherding and the maintenance of the SPIFFE specification set itself. So that includes things like, SVID specification, some of the federation work that Andrew spoke about and I'll speak about, the workload API, which is a part of the SPIFFE spec, is that kind of defines how workloads get the SVID, the certificates and identity to begin with. So that's kind of the scope of this group. So let's see. Since we last were here, we completed a specification called the SPIFFE Trust Domain and Bundle specification. I talked a little bit about it last time. Now that it's formalized, I'll just talk a little bit more about it again. This specification is kind of focused on defining the semantics of a SPIFFE trust domain, which is nominally kind of like an independent identity authority, and it is like backed by a set of keys. And you usually think of a trust domain as like one trust domain to one set of issuing keys, right? And then these things kind of peer together through this federation mechanism. And defining this kind of semantics was like a prerequisite to get federation working, right? There's a lot of confusion around what trust domains are and how they interact with each other. So that's kind of the goal of this spec. Along with that, we also kind of define what we call a SPIFFE bundle. And this is how those cryptographic keys are represented. So if I say I have authority A and it has signing keys 1, 2, and 3, how do I package those things up and actually represent them? This is, again, a prerequisite for federation because we end up having to ship these public keys across the wire and trade them between different providers in order to accomplish that. So this specification defines those two things, and then the final thing that it does is it kind of it affords like a lot of flexibility on how these bundles move between trust domains or move between control planes. That came with like a lot of how should I say? There were a lot of people in the community requesting a great deal of flexibility on this point because people have a desire to kind of invent their own kind of distribution mechanism. So maybe they take one of these bundles and stick it in S3 and then point a bunch of things at it. Or maybe they have a configuration management system that is able to like pick them up out of one part of the infrastructure and dump them into a different part. So flexibility on how these bundles move around between trust domains and between SPIFFE control planes was something that we heard from a lot of people. So this spec kind of doesn't go so far as to say exactly how it will happen, but it gives some recommendations to say, hey, here's one way to do it, here's another way to do it, but you don't have to follow that. So this spec is done and in. If you want to see it, it's in the SPIFFE GitHub repo. So that's great. This kind of really opened the door for federation. And paved the way to make that thing possible. The work that we're doing now is a little bit more concrete in terms of like those transport requirements. So, we've enabled this concept of federation through the work that we did in the last spec, but we didn't, because we left so much room in the transport part of the spec, because we didn't really say like you must support this or you must support that. We missed the mark a little bit in terms of like strongly branded interoperability. Like, hey, I have this software and it has this stamp on it, and this software that has this stamp on it. Like, can I have a guarantee that they're going to work together? So this new spec that we're working on, which is roughly titled SPIFFE Federation, essentially makes like some minimum requirements on what is supported in terms of bundle transport. Most of the text is actually being pulled out of the existing specification, trust domain and bundle specification. And some of those shoulds are just being upgraded to must. With the idea that if we say, hey, there's this minimum bar that you must support, and we say that across the board, then if you're compliant with this SPIFFE Federation spec, we can guarantee, hey, you're gonna know how to do this kind of authentication over TLS with HTTP to get the bundle in this fashion. So It's not to say that we don't have it today. We do have it today. It's actually available in SPIRE right now. But we just like to tighten it up a little bit more to give a stronger interop. So I don't expect this to take very long, since most of the text is already written. And we're just kind of like making it a little bit more rigorous. One other thing that we're thinking about including in this spec is a configuration or discovery mechanism. When you want to go and wire these trust domains up together, there's like a number of things that you need. You need like the endpoint address information. You may need like the identity of the service which is serving that bundle. You may need to understand exactly how to authenticate or validate the remote service, whether it's TLS or something else. So there's a handful of stuff that you kind of have to configure into your control plane in order to light all this up. So this bit of work has come from a request of a few folks in the community where they want kind of like the kubectl apply -f, kind of semantics, where I can have this thing that has got all the configuration information and I can just dump it into my control plane and have it light up and work. That's kind of the current quote state of the art, at least what we're working on actively right now in SIG-SPEC. So we're not quite sure exactly what that might look like, or if it will even go in. There's a little bit of questioning about how different configuration paradigms across different kinds of control planes are going to work with each other, and what this will actually, how it will actually be manifested when we get there. So that one is a little bit more shaky, but we'll see. So as I mentioned, this is available today in SPIRE. It's marked as experimental, but only because we're not quite sure how folks are going to want to configure these relationships. If you'd like to check it out, please do drop in Slack channel. We'd love to hear from you. We have some issues open, trying to gather some information from folks on the way that they would most prefer to consume this. The code is all very stable. It's more just kind of formalization of the configuration interfaces. So I'm also going to give the SPIRE project updates, but I'll stop there and see if there's any questions on the work that we've been doing in SIG-SPEC last 5 or so months. Okie dokie. So this is the SPIRE project update. So SPIRE is the software system which implements a software system which implements the SPIFFE specs. It was originally meant to be kind of a reference implementation, but has grown to be a fairly robust software project that is built for production. So since we last spoke at Community Day, which was I mentioned about 5 months ago, we've had 3 releases with 12 major features, over 170 merged PRs and 22 contributors. And you can see that this is a 40% PR growth period over period from the previous Community Day, and 20% contributor growth period over period from 9 different organizations. So I think you saw some of these contributor stats that Andrew shared, and I just kind of wanted to reiterate here because it is an incredibly healthy project with a lot of input from a lot of different people. So we're seeing some really great growth there, and thank you to everyone who has kind of been involved and pushing the ball forward on SPIRE. So in the last period of time since Community Day, we've been spending time validating different deployment topologies of SPIRE. So that is, we have a feature called nested SPIRE, which allows you to kind of roll SPIRE clusters up into each other, which provides like intermediate authorities, so you don't always just have like a root and a leaf. That gives a lot of flexibility in terms of like failure domains and things like that. We've also been playing a lot with the federation stuff that we wrote. That's all looking really great, and that gives flexibility both in failure domain, building around failure domains, and also building around security boundaries. So we've been focusing a lot on kind of like, how do we provide features and that ensure that SPIRE can kind of meet this variety of use cases and span different data centers or regions or cloud providers or what have you. So there's been a lot of work in core to kind of facilitate these different deployment scenarios. The second thing that we've been spending a lot of time on is performance work. So there's been a bunch of work done, and we have the data store plugin that most people use by default as a SQL based. So there's been a lot of performance optimization done there by a lot of the folks at Uber and Andrew Harding, and we've seen really great progress. We put in, the Uber folks in particular have put in a lot of really robust telemetry data into the project for visibility into where performance bottlenecks are being hit in larger deployments, as well as kind of like load balancing considerations for larger fleets of agents striping across a set of servers and failing back and evenly distributing that load, so on and so forth. And currently, what we're really looking at is ease of operation. So, SPIRE has kind of trended towards this expert system, if you will. It has a lot of different configurables, and it is so flexible that it can kind of be, there's a high barrier to entry in ramping up and understanding how everything works. So we're trying to make that better as best we can without killing our flexibility. One of those things that we worked on some time ago actually is to give you just an example, is automatic registration of workloads in Kubernetes. So when you deploy a Kubernetes workload, we have a little widget that will automatically inform Spire, like, hey, we deployed this thing, and here's a SPIFFE ID you should give it, and these are the details you should expect to come up. A lot of focus on sane defaults, limitation of config sprawl, trying to be really kind of careful about the knobs that we expose and think through them in a way that, hey, we think this makes a lot of sense, but is a new user to the project going to kind of be confused on this thing? Another kind of piece of work in that bucket is just better READMEs, documentation for all the SDKs. We have a lot of this stuff is out there, but it's kind of hard to find, and it's not written up in a way that is easy to consume. So all of these things are kind of going towards this push for ease of operation. And the final thing that we're focusing on right now is project process. So when I say that, I mean, things like making sure that our contributing guidelines and maintainership guidelines are all up to date and buttoned up very well. Focusing on release engineering and release planning. So putting in RFC processes, better issue tracking, just in general getting more mature about release cadence, release cycle, release safety. So speeding up that release cadence, there's been a lot of work that Andrew Harding's done recently in integration tests and compatibility tests, so we know if we've broken older versions and things like this. So, you can kind of see that the progression here is we're really kind of starting to work towards 1.0, and you can kind of feel it coming, hopefully this year, I think maybe December. But speaking of releases, we have just cut a 0.8.2 release, and we will be cutting in the next couple of weeks a 0.9 release. And I'm going to pass this off to Andrew, who will talk to us a little bit about what to expect there.
So I forgot my little name tag thingy, but Andrew Harding, work full-time on SPIFFE and SPIRE at Sitel. And like Evan mentioned, we had over 170 merged PRs between last community day and now. And so it was kind of hard to pick, what exactly we wanted to showcase here at community day, but just a preview of what's going to go into 0.9. First up, we've got this AWS Certificate Manager private CA-based upstream CA plugin. For those unaware, SPIRE server maintains its own CA that it uses to mint the X509 SVIDs in the system. And that can be self-signed, or if you're configured with an upstream CA plugin, instead of self-signing, it creates a certificate request that it hands to the plugin, and the plugin is in charge of figuring out how to fulfill that request and sign a CA certificate to hand back to SPIRE that, again, it uses to mint these X509 SVIDs. So last community day, we brought up a mention of an upstream CA plugin that had been added to the system based on the AWS Secret Manager. It would suck down the private key and certificate chain for the CA, hold it in memory in the plugin itself, and do the signing operations directly to hand back that intermediate CA to SPIRE. We have an open PR. It hasn't actually been merged yet, I don't think. Close, super close. Probably Monday, maybe sooner, who knows. That leverages the private CA feature set inside Amazon. And instead of the private key just being held in the secrets manager and pulled down into the plugin itself, that key is maintained inside Amazon Cloud HSM. So it's hardware backed. And the plugin takes the certificate request from SPIRE and passes it through the Amazon APIs to the private CA API set to get that, that request signed and the certificate back that it hands back to SPIRE. And so this is just, this expands our story of this, of the SPIRE cluster itself never needing to store keys on disk. If you have your SPIRE server configured with the memory key manager, your keys will never touch disk, and you can use one of these upstream CAs to get your stuff signed and never have to persist it somewhere where it might be compromised. So next up, we've had a lot of work done both through some more aggressive code checks and through our contribution process to kind of build out a better story around upgrades and downgrades of SPIRE server, particularly when it comes to SQL schema migrations. So up until now, there has been less, as we've been moving fast and building stuff out, there has been less rigor around how schema changes have been introduced in the project, and typically they've been introduced and used inside the same release. And so as you roll out a new SPIRE server into a cluster, first of all, you can only move forward. You can never move back because we didn't have any downgrade support on the schema change. And as your SPIRE server moved forward, it would start to interact with the database in ways that other SPIRE servers that had not yet been upgraded yet were not doing, obviously. And so you got into the situation where you had to kind of move your SPIRE servers forward all at the same time. And once they were forward, you could never roll them back. And you can see how in large cluster deployments that might be problematic. And so we've done a lot of work there. Andrew Moore from Uber did a lot of work in the code towards this end. So now our guarantees are a little more flexible. We guarantee that you can have a mix and match of SPIRE servers in your cluster, plus or minus one version, and things should still operate correctly. We have a contribution sort of guideline where if you're going to introduce a schema change, that you introduce the schema change in one release, but not actually consume those changes until the release after. And that way, if you roll out a new SPIRE server, something goes wrong, you want to roll back to the previous version, even if the database schema has migrated, you should be able to safely roll back and still be able to interoperate with the database without causing problems. So I think that's a big win in terms of deployment robustness for the project, and so we're happy to have those set of contributions in. So next up, improved agent management. So last release in the 0.8 timeline, we released a few commands around agent management, and this was mainly around listing what agents have attested to the SPIRE server and the ability to evict certain agents from the SPIRE server. And that was useful. A lot of our attestation methods for agents are trust on first use. So as you bring up an agent and it attests, we don't want you to reattest using that same credential for security reasons. And so we don't allow an agent that has once attested with a credential to come back and like reattest using the same credential without first being evicted, which is an explicit action that an operator takes, saying that, yeah, I want to trust this agent again. I want it to be able to reuse that credential for attestation. Maybe the agent fell offline for too long and its SVID expired, so it needs to like reattest back into the system. And so as an operator, you can meaningfully go and evict that agent to let it back in. We gained in this timeline some more agent management commands that expand that story a little bit. And this is the ability to drill down and show more specific details about an attested agent, like when does its SVID expire, what's the serial number of the SVID, and most importantly, what selectors do we have about that agent that we gained through the attestation process, which is really helpful in debugging. Let's say you've got some workload registration entries tied up to a node set that you're building out. Like these nodes are in a similar, have some similar selectors. I want to kind of group them together and allow them to run a set of workloads. And maybe my agent that I just brought up online isn't getting those workload registration entries. So it's not being matched up to the node set. So the ability to go in and dig down on what selectors we have about that agent and kind of reconcile that with the selectors you have inside your node set to figure out where they're misaligned is a really important, it's a very powerful capability when debugging the system. So next up, several releases back, SPIRE server gained a new plugin type called the key manager. And the key manager is used to both generate and persist keys that SPIRE server uses to mint X509 SVIDs and JOT SVIDs. And even though we gained this key manager that allowed for multiple different key types, whether ECDSA keys or RSA keys of different sizes and strengths, SPIRE server has still up until now been hard-coded to use specific key sizes for different purposes. We've just opened that up. We've allowed that to be configurable. There's been several community requests along these lines, particular environments that say are better suited for RSA because of some hardware crypto modules or things that they have deployed. And so we've now wired that up where you can now configure SPIRE server to use particular key types of sizes. Basically, most of the stuff that the key manager supports. I don't think we included all the key types, but you can use most of the key types and sizes that the key manager supports now. And last but not least, we'll get into this a little bit later. We have a demo kind of showcasing this last thing. This goes along with the federation story that Andrew Jessup talked about and Evan talked about. But we've got a little new process that we've introduced into the SPIRE family. And it's just a little teeny OIDC discovery provider. It connects to either the workload API, so you can register as a workload and connect to the workload API, or connect directly to the registration API on the SPIRE server. And its whole job is to retrieve the bundle from either of those APIs, to filter out the contents of that bundle to the subset of keys used for signing JOTs, and to provide both the well-known OpenID configuration file, serve up that endpoint, as well as the JSON Web Keyset URI. And so this enables you to kind of federate with, do OIDC federation using this little shim. And it has support for obtaining certificates for WebPKI via Acme. So you can, stand it up directly in a public spot and have it serve up WebPKI to protect those endpoints. And so, I mean, this is just a small subset of those 170 PRs that came into the project. We've got across these PRs 4 different companies contributing to the project, which is awesome. Like, we're super excited for the level of contribution that everyone's making and the way that everyone's pushing the project forward. And I'll turn it back to Greg. All right. Any questions?